recent breakthroughs in 3D computer vision means we can make beautiful, photorealistic 3D worlds just like this. But there's a catch. It takes a lot of time and a lot of GPU resources just to make a scene like this. But what if I told you you could build this exact scene on the screen right now, and it only took 11 seconds from start to finish to build everything? That's right. The original team that made 3D.js has just come out with a new project called On-the-fly NVS, which is short for, let me read it, On-the-fly Reconstruction for Large-Scale View Synthesis. Yeah, that's a mouthful, so I'm just gonna call it On-the-fly NVS for now on. I'm gonna dive into this code. I'm gonna talk about how it works on a kind of a 50,000 foot overview, but then we're gonna see, is the scene I created in 11 seconds better than a scene that I created in 40 to 45 minutes on my same computer? So at the end of this video, you're gonna see how this stacks up against the current version of 3D.js that most people use. I'm gonna use Postshot. And then I'm also gonna show you the code and some gotchas. So let me start by explaining why this project is such a big deal. Not only is it fast, it also approaches something called scale, and it uses a very intuitive way of figuring out where your cameras are and then creating a scene that's optimized with Gaussian splatting. So if you look at how it's currently made today, a lot of times we're waiting for 45 minutes, an hour, maybe 3 hours, because it's plugging along at what's called structure from motion. It's figuring out where I have a bunch of separate images and where they belong in 3D space. If you're using something like COLMAP, which is an open source project for that, it can take you easily 15 minutes for a very small set of images to hours for large sets of images. And so what they do with On-the-fly NVS is they say, I'm gonna see some photos and I'm not gonna think back over the photos taken in the past. As it moves along, it's kind of not forgetting, but it's storing in memory what it saw in the past. So I'm able to speed this up, and they did a lot of enhancements to figure out where those cameras are in 3D space in a blazing fast speed. We're talking, instead of hours or minutes, we're talking about like seconds. I don't know, it doesn't even tell me how fast it takes. The next thing it's doing is when it's optimizing the scene, when you're doing Gaussian splatting, you end up with all these, you have a point cloud, you have all these points, and it's saying, those all become Gaussians. All of a sudden you have hundreds of thousands of Gaussians in your scene, and it's trying to optimize them, and it ends up being millions of Gaussians. What this does, let's say I'm moving along a corridor, it's gonna say, I see this part of the scene. I'm gonna optimize the Gaussians just for this part of the scene. And as I go further along, I'm only gonna refine the parts I need to, and then I'm gonna store all those parts in memory and move along and optimize the next part of the scene. So if I did like a long street corridor, when I get to the end of that street corridor, the stuff at the start, it's not forgot about, but it's no longer thinking about it. So you're able to really speed things up. And they say in the paper, they have some of these scenes that would take 22 hours, and they're doing it in a very small amount of time compared to that. I'll put on the screen what they showed. So that's the paper. And for most people, they don't really care necessarily how this all works. All you need to know is that it's super fast. And so with that, I'm gonna jump into more of a hands-on part. We're gonna look at the GitHub page. I'm gonna compare 3 data sets, and we're gonna see a small scene, a medium scene, and a large scene. And I'm gonna show you how fast each one trained and how they compare visually back to back. So you can decide, is that speed worth it to you? Here's the GitHub page. And like always, I will make sure that I link this in the description notes for this video. So I ran this all on my computer, and I'm gonna run one just so you can see how fast it is, but you just need to set it up if you have Ubuntu or Windows 11. It says with PyTorch 2.7, include 11.8 and 12.8. I think I used PyTorch in 12.6 because I don't have 12.8. You just have to make sure you get the right matches. It worked fine. And so basically you're gonna pull the code. Just gonna work through this, guys, really quickly. For the people who wanna run it, you're just gonna change directories and then create a conda. It's called On-the-fly NVS and conda, and activate it. And so once you've done that, you're able to bring up your command prompt just like this and make this big. And I'm just gonna say conda activate On-the-fly in NVS, like so, CD on like this. And so now I'm like ready to go. And that's how you initialize it. And then they have a few other things. You need to install these Torch Vision Xformers and these couple other things. I do want to tell you, this took a while to build. I think these 3 parts took like 20, 30 minutes finally to finish on my really fast computer. So just be patient. It will work. You just might have to wait. But I don't think I ran into a single gotcha on this. It just worked out of the box. And if it doesn't for you, comment on that as video. I would love to see if I can help figure it out for y'all. And then they get into some gotchas on the data guidelines. So this says, please note that our method is not a drop-in replacement for COLMAP plus 3D-GS. It's not exactly the same. So what they mean by that is basically when I am doing a scene and using COLMAP, I can take pictures all around a room, all around a scene, and they don't have to be sequentially taken. I don't have to take a photo, move 2 steps, take another photo. It just has to be a bunch of random photos of the scene, and it'll figure out where those all belong. But the way this intuitive system works is it's thinking everything sequential. So as it gets further down the sequence of images, it's storing in memory the old images that it's already seen, not having to revisit those and move really fast. So just think this is perfect if you're walking around with a video and you want to capture in a sequence, because those are just image after image. But if you want to take a bunch of random photos, walk around, photo here, photo over there, and do things like that, it's not going to work. And they have a whole guideline. So let me jump back to that. They have a whole guidelines on how you set this up. They have to be, like in alphabetical order, using PNG, JPEG, things like that. And you can do that. So just read through this carefully. They have whole guidelines here. You want to order it in sequence, and they have these good images of seeing. You want to make sure they're not out of order. You want to make sure you're moving, things like that. And it's pretty easy to get going. If you ever use 3D-GS, this will not be hard for you to figure out. So then we get into what's called optimization. And that might be kind of confusing. Why that term? That is basically just saying training. I am training the scene. So I'm going to start by training this scene of my cat just to show you how easy it is. I'm going to pull this up and I'm just going to type in Python train, and then I have to have this like source of where it is. Mine's just in called data cat. And then I want where the model is going to output. Since I already have one called cat, I'm going to call this results new cat. So if I go to my folder here on my computer, I apologize if this is a little small, but I have On-the-fly NVS folder, a data folder called cat, and I have some images of my beautiful cat, which I'll bring up on the screen here, of my cat who miraculously still stayed long enough. And you can see the pictures were taken in a sequence of my cat, a really small scene. And let's see how this stacks up. So if I go back to this, just gonna hit enter. And of course I have an error, figure out where I put it in wrong here. Python train, dot py. Of course I missed some small little thing. Okay, so now it's initializing. And the cool thing at the end of this, it's going to tell me how long this took to run. And you're going to see it's really quick. Okay, so now it's training. And you're going to see that it's predicted to take, 30 seconds, around that. And here's your real time. I will, at the end of this, show you the speed differences as well compared to Postshot. So we're going to compare these results to Postshot when it's done. So it keeps going. And it's almost done. Saving the reconstruction, and it's done. Here we go. It took 39.37 seconds. And if I check my notes, I think that's longer than it did the first time I tried. Let me go look. If I check my notes, when I'm not running this web recording software, and I'm not running all this stuff to have this go in real time, it took me 33 seconds. So keep that in mind. It said 39. I think it took 33 when I didn't have a bunch of stuff already waiting along. So let's look at those results though, because that's really where the proof is. So if I go here, there's optimization. We don't care about evaluation. What we care about is an interactive viewer. We're just going to use this example right here, which you can copy. I'm going to paste it. And all you need to do is, wait, wrong one. I'm going to go to this one, visualize and reconstructed scene. Go here and just change this results to my results, new cat. Here we go. It launches right into your browser, which is super easy. And now I need to kind of resize some components. It does that I don't think I can resize this cat. I think there's a way you can launch to resize that. So it will be kind of small on the screen, but I will do some magic. So here we go. And as you can see, that is a great cat. That's looking really good. You can see like fine little hairs. And this is a really cool viewer. I can look at the depths as I move along. There's not a lot of noise. I can look at the ellipsoids, which is like crazy how it optimized, and go back to the splats. And it doesn't have, I guess, the best way of moving around. You can play around with that. You can even get this top view to see where like my virtual camera is in relation to that cat. But then I can do another thing where I can go down here and say, look at it by camera keyframe, so I can see how well it reconstructed each photo that I took. And I did this from a video, so they're not even like perfect stills, but you can see it did a really good job. Like, this is really good. So this is promising because I'm about to show you the post-shot version of this, and keep in mind how good this looks, considering what it took under a minute, it took 40 seconds or something like that. I can even play with like my field of view and things like that in here. Oh, here you can change my resolution to make it bigger. Look at that. I'm learning as we're on this video together. So now I got this full screen, and then I can move around. So just kind of like think about that. This is really cool way to view my cat, and that they built this all in. So while this is cool, let's open up Postshot and let's see how it compares. So let's go to open recent. My cat. So here's my cat. You can see the camera poses, things like that. I'm going to turn them off. Just have the radiance field. So again, I don't have any hard metrics on like evaluation metrics, but as I'm moving around, to be honest, I'm not sure which one's better. Like things, if I got to change the movement here to free, you can see like the table around here is like almost better in this scene. Things are getting a little tough because I got both going at once. So let's just look at this one. But it almost did worse. And so I used Postshot in their Splat 3, and it almost has some holes. So if I was to compare these two, I would say On-the-fly NVS 1 on this small little scene, which just blows my mind. And I'm going to also put here on the screen, here's the time difference. This is the big one. This one took, for my cat, 16 minutes and 18 seconds start to finish using Postshot. Now, I didn't use any sort of like reality capture or anything. I just used straight images in there, and I made sure I matched the resolution for both of these because they will downsample the resolution on the fly NVS unless you don't tell it to. So I made sure everything was 1-to-1. So when you think about that, 33 seconds on my first test versus 16 minutes and 18 seconds, we're looking at almost like over 15 minutes of speed up. If I was to do that in like, that's like what, 50, 60x in speed, that's crazy. And do keep in mind, again, I have a really fast computer. So this trained fast, if you had not such a high performance computer, we might be talking the difference of like, I don't know, a minute versus 45 minutes on this scene. So now I'm going to look at a couple more results. I decided to move up in size of scene and see how well that did. So if I did one of me, of course, I had to do a selfie. So if I go to my data, I did one of myself, and it's me at my alma mater. I use this data set a lot. It was captured with an iPhone in a pretty wide aspect. And it was basically my wife walked around in a big circle and took a bunch of images. It was like 309 images. And just for some reference, I'm not going to train this one. I'm just going to give you some numbers. This scene took 34 minutes and 13 seconds to run on Postshot. So let's look at those Postshot results first. Let's do it in reverse. And I think the results on this one turned out really good. Like specifically this building, like it's super sharp. You got these great details. I use Splat 3, which I am finding not always is the best results, but promise me the difference between Splat 3 and ADC and MC, if you know those, they're like not night and day difference. Some are better at some things than others. And I'm kind of fuzzy in some of these. I think that's because the camera positions they got weren't perfect all the time. And I wasn't always in focus, but from, some of these viewpoints, I'm a lot sharper. But again, you saw it was like a really wide shot, And this looks cool though. This is like a really cool scene. And let's see how it did with On-the-fly NVS. Okay, for On-the-fly NVS, it took a total of 73 seconds to create this scene. So we're talking like a 30x speed improvement on this specific scene, which is really fast. And let's see if I can make this bigger for you guys as we learned our new trick. And this might like torpedo my computer, but here we go. Hopefully I don't crash my computer. I think I'm gonna crash it with such high resolution just because that's a lot of splats to render at once. Okay, I reset the intrinsics. I think it was just too much. And just looking at this, I just know this isn't as good. I feel like you look at me, I'm not great. So while we had what a huge speed increase, the building behind me didn't look right. I'm not sure I'd want to use results for much of anything. Some of these views are somewhat better than others, but overall it's not great. And to that point, if you read the GitHub page and read about the project, it'll tell you it doesn't do what's called loop closure, which is going to be the next video I make. But it's going to be basically saying as I walk a loop around a scene, when you get back to the start, Sable will say, aha, I didn't quite figure out where your camera positions were perfectly, but now I've returned to a point which I understand. Yeah, it can fix everything, but it doesn't. And since I walked a full loop in this, or my wife did, as she walked around, when she got to the end, there might have been some overlapping images, especially when it's looking at my face, and it's getting really confused because those cameras they call drift. And if those aren't perfectly where they are in real life, things look worse. And that's why it's really important to have good camera positions before you start training these scenes. So I'm not going to jump back into this one. I showed you enough of it just to know this medium-sized scene, not great. There's a lot going on. There's trees, there's buildings, there's me. And I would, in my opinion, I would easily wait an hour for that result. Why would you want to get a not great result really quick when you can get great results faster? So that made me think maybe it has to do with something that the fact that this scene, I used a wide aspect camera, you use a vertical camera, and maybe it's not the size of the scene, maybe it's something else. So I'm going to test one more scene. It's even further out. It was a drone. It was using your normal wide aspect, just like you're watching this video on, and it's a bunch of images of a castle in Slovakia. And this one, I think, is a good comparison of what I expect more often than not. It wasn't also a full loop, so I didn't come back to the start. So when it got to the end, it was kind of like all novel. So here's my results from Postshot. It does have a little bit of cloudiness at the bottom. That's just because I hadn't really seen it from there. Let me turn off all these elements. But you can see, again, this is Splat 3. I have done this castle so many times. I think ADC got me the best results. This is default. I made sure I matched the resolution of the imagery and nothing else changed. And this looks really good. If I do pull up the camera trajectory, which I didn't on all of them, you can see I kind of like flew this loop. So it was all captured like this. And so if you get close in, you don't have any of that, sky hanging above, and it looks really good. And if I run this thing, I think I ran this to 30,000 iterations. You run this thing like 100,000, you really up the amount of splats. This thing looks like a perfect photorealistic model. But this is what you expect. And so for timing on this one, this castle, I did a little different. This time I decided I'm going to skip using the COLMAP built into Postshot, and I'm actually going to use reality capture because it's much faster and in some ways more accurate, sometimes not. But that took 3 minutes to run. So we're going to say that's a big speed up. I tried using Postshot, and Postshot was taking a long time, and I got impatient. So this scene could have taken an hour in Postshot, but because I used reality capture and let Postshot train it, it only took about 10 minutes, which is really fast. But that's like the Splat 3. But I've done this one in the past, and to get the best out of it, it can easily take up 45 minutes to an hour using ADC and not downsampling to a really low resolution image. So that's fast though. So keep in mind, this took 9.5, almost 10 minutes to run on Postshot, and this is what you expect results. So I'm going to close this, and we're going to look again at the one from On-the-fly NVS. And here it is. And keep in mind, this was the scene that took 11 seconds. I had to run this one more than once to make sure that was right. And every time it took about 11 seconds. So this is already, to me, looking as good or close to what we got from Postshot. There's some weird floaters out here, and I don't quite know why, But for the most part, the castle, the main part of the scene, it really optimized well. I'm going to make this a little bigger and hope it, again, doesn't ruin my GPU. It's a lot to render. Okay, here we go. And then if I go to the depth, it does depth. And you can tell there's some areas it didn't have as much detail as I would expect. But again, it's fast. And here's my ellipsoids that it optimized. There's a ton of them, but it kept some pretty large. If I go back, some of these areas, it basically kept this as one big large splat down in here. That makes sense. There's not a lot of details for it to latch onto, especially with the low resolution downsample. Think about all these were about 16 to 1700 pixels as the longest dimension, all around a 1.5 megapixel images, I think 1.6. And that's what they tend to like to do with these projects. So I could have ran it at a higher resolution, but I may have ran out of GPU space. Don't quote me on that yet. So this is looking really good. I also don't know the frames per second. I don't know if I can bring that. Oh, maybe I can. FPS and status bar. I don't see that. Oh, down here. So this is rendering at 100, it's by my head, at 177 FPS. So it's incredibly fast. And that's at like, what, 2K resolution. So again, fast, really good. I was shocked by these results. So I think that there is a valid reason to use this. On small scenes, it looked really good. On a really large scene, not using vertical video, I think it also turned out really good. So I think this warrants some actual testing on your end if you want to see if the speed up is worth it for you. But I did want to bring up one thing about speed that most people don't think about. If I'm out in the field and I'm capturing images and I want to make a 3D Gaussian splat scene, speed does not really matter because most often I don't actually need that model right there while I'm outside. However, you can easily capture these scenes using all sorts of free apps right now and some paid ones and just upload them in the field. And by the time you get back, everything's ready because they can process these really fast using a server. And if you yourself want to be a developer and want to really build on this, you could easily stand up your own like server development at home. I'm training this on a NVIDIA workstation GPU, but I could always push this out to like an array of H100s from NVIDIA and do the best model possible and have my results still in like a few minutes just because that compute resources are so fast. So at the end of the day, we are getting faster and faster with this technology. The results aren't always as good, but they are getting close to what the state of the art is in a fraction of the time. I'm really excited to see where this goes. So it's amazing what the team, the original 3DGS team, has built here. So if you're this far in the video and you found this video somewhat insightful, could you do me a favor and subscribe? It means a lot to me. I am trying to build a base of people who care about this technology and are vocal and want to share about it because that is what is pushing me to do more of these. So anyways, with that, I will see you guys in the next video.